Hi, today I'm going to teach you how to do problem number 42 of chapter 5. So this problem states, 3 objects are connected on a table as shown in figure P5.42. The rough table has a coefficient of kinetic friction of 0.350. The objects have masses of 4.00 kilograms, 1.00 kilogram, and 2.00 kilograms as shown, and the pulleys are frictionless. Draw a free body diagram for each object. Determine the acceleration of each object and their directions. Determine the tensions in the 2 cords. So I have copied down the diagram that was given in the problem, and now I'm going to draw a free body diagram for each individual object on the diagram and show all of the forces. So for the 4 kilogram object, there's the force of gravity, which is mg, and tension, which we're going to call tension 1. Then for the 2 kilogram object, we're going to have the same thing. So tension, and we're going to call this tension 2, and mg once again, or mass times gravity. For the 1 kilogram object, there will also be mass times gravity, and there will be the normal force, which is perpendicular, and there will also be tension 1, which is the same chord here, going this way, so that's T1, and tension 2, which is the same as this, going this way. And there will also be friction, and when we look at this diagram, we can think about, since this is 4 kilograms and this is 2 kilograms, obviously using common sense, we know that the entire thing is going to shift this way towards the side of 4 kilograms. So we know that this is going to accelerate this way, this will accelerate this way, and this will accelerate up. And since the 1 kilogram object is moving to the left, that means that the friction, the force of friction is going to be going the opposite direction. And for, we're going to use positive x in this direction and positive y in this direction, and we're going to use that for all 3 of these free body diagrams. So now we're going to start with Newton's laws and do the sum of all the forces in the y and the x directions. So the sum of the forces in the y direction, and we're going to call this y1 for this side, is equal to T1 minus mg, and that's going to equal m negative a. And the reason it's negative a is because we called this the positive y direction, and it's going to be accelerating downward, which is negative. So now we plug in our values, so T1 minus 4 kilograms times 9.8 meters per second squared equals 4 kilograms times negative a. So simplifying this, we get T1 equals 39.2 minus 4 kilograms times acceleration. So that's what we have for this. So now we're going to do the sum of the forces in the y direction for the 2 kilogram object. So sum of forces, and we're just going to call this y2, and that's going to equal tension 2 minus mass times gravity equals ma. And this time the a is positive because the object is going to be shifting up, which is the same as our positive y direction. So we're going to have T2 equals negative, sorry, my bad. So we're going to have T2 minus 2 kilograms, 9.8 meters per second squared, and that's going to equal 2 kilograms times acceleration. And when we simplify this, we get T2 equals 19.6 newtons plus 2 kilograms times acceleration. So now we have to look at the 1 kilogram object. So what we also know about this is this was given in the problem that the coefficient of friction is 0.350. So that's going to help us in this one. So first we're going to do the sum of the forces in the y direction. So that's going to be F, and we're just going to call this y3, and that equals normal force minus mg, and that equals ma. But since this object is not moving up or down, we know the acceleration is going to be 0, so we can make this entire thing 0. So Fn, or the normal force, is equal to mass times gravity, and we know that mass times gravity is going to be 1 kilogram times 9.8 meters per second squared, so that's going to be 9.8 newtons. So also, we're just going to solve for friction just so we can plug it in later when we use it. So friction is going to equal coefficient of friction times the normal force, which we just found. So that's going to equal 0.350, which was given, times 9.8 newtons. And that's going to equal 3.43 newtons. So still looking at the 1 kilogram object, we now need to do the sum of the forces in the x direction. So sum of forces in the x direction is going to equal, and remembering that this is positive, because that's what we decided at the beginning of the problem. So the force of friction plus T2 minus T1, and that's going to equal m times negative a, and it's negative because this entire thing is going to be moving this way, and that's opposite of what we decided positive x would be. So when we just plug in what we found for the friction, we isolate a, or negative a, we get 3.43 newtons plus T2 minus T1 equals negative a, because the mass of this object is 1 kilogram, so it's going to equal negative a. So now what we have 3 variables, tension 2, tension 1, and acceleration, and we also have 3 different equations that we found right here, here, and here. So now we just do a simple 3 variables, 3 equations to solve for our variables. So since we already have what T1 and T2 equals, we're just going to plug that in right here. So 3.43 newtons plus T2, which is 19.6 newtons plus 2 kilograms times acceleration. And then we're going to subtract T1, and that's 39.2 newtons, minus 4 kilograms of this, so that's going to change to a plus. And this is all going to equal negative a. So when we just rearrange the equation, simplify a little, we get negative 16.17 newtons equals negative 7 times acceleration, or technically negative 7 kilograms times acceleration. And then this causes acceleration to equal 2.31 meters per second squared. So this is the first part of the problem that we're supposed to solve, and that's A. And also for A, it asks you to say which direction the acceleration is going, and we already explained at the beginning of the problem. Since this side is heavier than this side, and due to gravity, it's just common sense and quite obvious that the entire system is going to move in this direction. So acceleration for the 2 kilogram object will be up, acceleration for the 1 kilogram object will be to the left, or negative x direction, and then the acceleration for the 4 kilogram object will be in the negative y direction, which is down. So now we're going to do part B, which is simply to find the tensions in the 2 ropes, and this is very simple since we already have an equation for each tension. So all we have to do is plug in the acceleration that we found. So T tension 1 is equal to 39.2 newtons minus 4 kilograms times 2.31 meters per second squared. And this is going to be about 30.0 newtons. And tension 2 is equal to 19.6 newtons, and then plus 2 kilograms, and plugging in the acceleration, 2.31 meters per second squared. It's going to equal 24.2 newtons. And then this is both part B. So we just solved the entire problem. We found the acceleration of all the objects, and we found the tension in chord 1 and chord 2. Thanks.